Adding and subtracting rational expressions is going to fall right behind, right in line with what we did yesterday. It's not too complicated if you can remember how to find common denominators, stuff like that. Now, the thing that you were supposed to have copied down a second ago is to add or subtract rational expression, you must find the LCD, least common denominator. That's what we're going to do most of the time. Okay? The LCD is the LCM of the denominators. Okay, LCD and LCM are essentially the same thing, but LCM is only used when you're not dealing with fractions. LCD is used when you're dealing with fractions. So the first thing that we're going to do is we're going to start by practicing finding the LCM. So, in example 1 here, let's say I want to compare 15a squared bc cubed. So 15a squared bc cubed, okay, and I want to compare it with 16 b to the 5th c squared, and then I want to compare it with 20 a cubed c to the 6th. Okay? So if those are the three numbers I'm looking at and I want to find the LCM, least common multiple, because we're not dealing with denominators right now, I want to find the LCM, I'm basically going to have to prime factor all those numbers, okay? Which is not a big deal. It's pretty easy. And what I mean by prime factor, let's start with 20 because it's a little easier to see. If I want to do prime factorization on 20, that's when you used to do your factor tree, right? And then you have, actually, let me do this. Let's do 16. No, we'll do 20. Okay, so 5 and 4, right? So 5 times 4 is 20, and then you continue to break down 4, you get 2 and 2. So then, if I was talking about the prime factors of this, I would be dealing with
2 squared times 5.
2 squared times 5. Okay, so that's kind of what we're looking at. So if I look at 15, what are my factors of 15? 3 times 5 times a squared times b times c cubed. Okay? Over here on 16, what do I have? 2 to the 4th power times b to the 5th times c squared. And then here, we already figured out that we have at least 2 squared times 5 times a to the 3rd times 6. Or c to the 6th, excuse me.
Can you do it to the 2 something, 2, 3?
I'm sorry, what?
Can you do c 2 times 3? Okay.
No, you're not factoring out the exponents of the variables. Okay? So, those are broken down. So now to find the LCM, what I want to do is I want to take basically the number, the value, each separate value with the highest exponent. Okay, I think that's the easiest way to put it. So, for example, if we start with our whole numbers, what's the first number we see? Well, the lowest number we see. 2, right? And that 2, the highest exponent it has is what? So my LCM is going to be 2 to the 4th power times, what's my next number? No, I don't want that one now. I'm done with my 2. So what's my next? So 3. Okay, that's my next whole number. There's no other 3 to compare it with, right? Okay, so what's my next one? 5. Now I have 2 5s. Which 5? Either. It doesn't matter because somebody said it. They're both the same. So 5 to the 1st power, the 5 to the 1st power. Now I'll move on to my variables, starting with your alphabet. Okay, a cubed, that's my highest, right? So I'm going a to the 3rd power. Okay, and then I'm going to go b, 5th power, and c to the 6th power. I'm taking all my highest values, okay? Now what I would do from here to finally get my answer is actually work that out. So 2 to the 4th power is 16. 16 times 3 times 5 is... Anybody? Anyone? Huh? What is it? Anyone? 240. Anyone?
Whatever 480 times 5.
Anyone? 240. That's correct. 240. All right. So it's 240, and then all I got to do is match back together my variables, and I have 240 a cubed, b to the 5th, c to the 6th power. Whoops, I didn't mean to do that. C to the 6th power. And there is my LCM for this problem. No. This is like tiptoeing us into what we are doing. You just have to kind of understand the concept of finding these, because when we shift over to LCD is what we're going to do most of the time. Lowest common denominator most of the time. Now, in fact, chances are these are monomials. You're not really going to do a whole lot of this anyways, because what we're going to do now is our next example, which is...
LCD.
No. I just said monomials, so now we're moving into polynomials. So what if I compare x cubed minus x squared minus 2x, and then x squared minus 4x plus 4. In fact, let me do it this way. No, you're going to have those same things, but I'm going to do it this way to make it a little easier for you to see. So x squared minus 4x plus 4. So if I break this one down, when I start factoring, what do I end up with?
X cubed.
X comes out, and I have what? X squared minus x minus 2. If I continue to break this down, I have x times. We're factoring, right?
X plus 1, x minus 1.
X minus 2 times x plus 1. It's not a perfect square, so I don't know where that was coming from. So that's factored now. Again, we're comparing it to this one over here. Do I have a greatest common factor to factor out? No, so let's just go ahead and break down the factors. What do I have? So x, no, x minus 2 and x minus 2, right? Or how do I write that? X minus 2 squared, right? So now let's start to look for our LCM. Okay, how many different sets of values do I have here? No. 3. Okay? This is a value, this is a value, this is a value, this value is the same as this, right? So think about this as x, y, z. This just happens to be y squared, right? Okay, so when I take my LCM, I'm taking out the highest value. Well, how many x's do I have? 1, simple, right? What's my next one? 3. Okay, x minus 2 squared is what I want next. And then what? X plus 1. Well, ideally you want to put that square at the end, but that's fine. That all works. Because multiplication, right? So multiplication can be moved around. No, you leave it just like that. So that's your LCM right there. Okay, for you guys that are a little confused, remember, we have our values, right? What's our highest x value? Well, there's only one of them, so you bring it down. What's our highest y value? Remember, we just kind of dubbed this y. What's our highest y value? These are both y values. This one's got a square. That's why it came down. So this is my highest c or z value, and there's only one of them to mess with, so it's got to come down. Okay, does everybody follow that?
Yes.
Okay. All right, so let's use that as we really start to do what we're going to do for most of our homework. All right. So here's example 3. Example 3 says 6 over AB, so 6 over AB plus 8 over A. Can I add these together? No, why?
Because there's an AB on
They don't have a common denominator. That's the key. They don't have a common denominator because there's an A and a B on the bottom. Which one do I have to manipulate? Do I have to manipulate one or both? One. Which one do I have to manipulate? 8 over A. So you're telling me that 6AB is fine, right? I agree. What do I have to do to 8 over A? Times it by, and remember it's B over B, right? Why is it B over B? What is this?
So you can actually get A, B, and have a common.
Okay, that's 1. What does multiply by 1 do? Nothing. It doesn't change the value. It's going to give me my B, but it does not change the value of this problem at all. Okay, so then I end up with 6 over AB plus 8B over AB. And then this really turns out to be 6 plus 8B over AB.
It wouldn't be AB.
Can I do anything else? No, and he just asked, would it be AB squared? No, it also would not be 2AB, because when you have common denominator, it's like finding 1/4 of 1/4. Your answer is 2/4, right? Until you reduce it, it's 2/4. Your common denominator stays what it is, singular. Okay. Now, what is my lowest common denominator? What do we figure it out to be? AB, right? Okay, I know that seems like a trick question because, see, I teach it a little different. I let you guys figure it out because I think that you guys are smart enough to figure it out. A lot of teachers, what they'll do when they start, especially when you're in elementary, middle school, they'll say, okay, what do these have in common? Okay, figure it out. Let's multiply it together. Well, you guys figure that out without it. If I ask you that question, a lot of you will get confused and be like, okay, so I'm going to multiply this together. Well, then I add these together. Then do I multiply them together again because I just add? I let you guys work yourself through it, and then you can figure out, hey, my lowest common denominator is what I finished with. Okay, that's what I finished with. Okay, any questions on that? Okay, let's get progressively more difficult. All right, example 4. Okay, we're dealing with 3x over 4y squared minus y over 6x.
You could take the 3x and 6x, make it 1.
Okay, we're not going to do all that right now. Okay, we're not gonna, it's a good thought, but we're not going to do all that right now.
So you have to multiply by y squared and x.
Okay, so now both of them need to be manipulated, right? Okay, so what do I need to do to 3x over 4y squared? Multiply by at least x, so x over x. Is that going to do it though for me? Well, y is there. Think about the whole numbers.
4, 8, 12.
Am I going to have to do anything to the 4s and the 6s? Yeah, I'm going to have to do something to them, right? They got to be the same.
3.
So, okay, so he said multiply by 3. So 3x. Okay, hang on. Now, is this still 1?
Yes.
So it's still not going to change my value. Okay? So then I have minus y over 6x. What do I have to do to the 6x? Or y over 6x?
Times it by 2y.
Not 2y. Y squared at least.
2y squared.
2y squared. Oh, I see what you're saying. 2y. 2y squared. There you go. Okay? Now, let's see what we have. Let's go ahead and do all the math. 3x times 3x is 9x squared. 4y squared times 3x is 12xy squared minus, okay, y times 2y squared is 2y cubed over 6x times 2y squared is 12xy squared. Now can I subtract them? Yes, so that's going to lead me to this right here, which is 9x squared minus 2y cubed over 12xy squared.
How did you determine the 2y squared?
That was easier than one.
Okay, because...
Thanks, man.
Way to uplift him. All right.
I mean, that was so difficult.
Because here, over here, and this is the thing that everybody can figure out easy. Here on my denominator, I had 4y squared. So I'm missing the x from over here. So that's where the x came from. Well, over here, I'm missing the y squared that this has. So that's where the y squared came from. And then we realize, hey, the lowest is 12. So I need to get that 12, them to equal 12.
See,
Okay. All right, any other questions?
that was
All right, let's keep moving. Next example. This is where it gets fun. All right. Yeah. 7 over y minus 8 minus 6 over 8 minus y. Boy, these tick me off, don't they? They're so close to being the same. We have to do one little thing. Okay, not multiply -1, but Yeah, take it out, distribute it out, or factor it out. Okay? So here, are we going to leave 7 over y minus 8 the same? Yeah. But over here, what we're doing is, and I'm just going to kind of do a little sidebar. This 8 minus y, if you remember, we can switch it around and make it negative y plus 8. And then if we factor out the negative, like Alexis and Maria were trying to say, we take that negative out, we have y minus 8, right? So then what happens on the bottom here, this becomes 6 over negative 1 times y minus 8. Well, what happens to this negative 1? And that negative right there? They cancel out, make it positive. So now my new problem becomes 7 over y minus 8 plus 6 over y minus 8. Can I combine terms now?
Yes.
Yeah, absolutely. So this gives me
13 over 1 minus 8.
13 over y minus 8. Really? Any questions on that one? Apparently it was super easy.
Yeah, I don't even understand.
No, it just.
You didn't get it?
Nope.
You're like grammar.
That was easier than the last one.
I didn't say that.
I was waiting for Peyton to say that. All right.
I sleep over here, so.
Where are you? Oh, that was so easy. Where were you confused at?
Had everything.
At
He got lost.
when you wrote 7?
I forgot to write 8 minus y.
Okay. So basically, what I did here, and did we do this yesterday?
Yeah.
Okay, that's probably why you're not. So what I did was I took this over here, and I just wanted to show you how I changed it because my last class I just skipped all that because they got it from yesterday. You could have probably skipped a lot of that, but I wanted to show you that that's what we have, right? Initially. Well, if I change it around, you understand that that's the same thing, right? Okay. Well, what happened was I'm trying to make it look like this. If I take out a negative, if I factor that negative out, negative y divided by negative 1 is a positive y. 8 divided by negative 1 is negative 8. So this is essentially the denominator over here. So that just comes over here. I just brought it back. And so then what happened was, now you have 7 over y minus 8, and then you have a negative and a negative. Well, those cancel out and become positive. So then you end up with 7 over y minus 8 plus 6. That disappeared with that over y minus 8.
Only thing you had to try to do was get the same denominator.
Okay? Yes, sir.
What's the answers in the one?
Right there. Okay. Next. I don't think so. Okay. So now we have m over m minus 4.
My paper says m squared minus.
Oh yeah, m squared minus 4, excuse me. M over m squared minus 4 plus 2 over 3m plus 6. Okay, fun stuff.
Yeah, you gotta give us a square.
Okay, we have difference of squares. So, again, I have m over, if I change this to my difference of squares, what do I end up with? M plus 2 times m minus 2 plus 2 over, can I factor there? Yeah, what does it come out to be? Well, what's the first thing? 3 times m plus 2. Okay, now looking at my common denominators. Do I have common denominators? No, I need to make them. So, do I have to manipulate both of them? Yes. So, what do I have to do to this one to make it right? Multiply by 3 over 3, right? What do I have to do to this one to make it right? Multiply by m minus 2 over m minus 2. Oh, I lost my, there we go. Now, m times, let's go ahead and do the multiplication. M times 3 is 3m over 3 times all that other stuff down there, m plus 2, m minus 2, plus 2 times m minus 2 is what? 2m minus 4 over the same thing. We got our common denominators, right? 3 times m plus 2 times m minus 2. Okay. Now can I combine them?
5m minus
So now I end up with 5m minus 4 over 3m plus 2 times m minus 2. Boy, that's ugly. Yeah, it's not hard. It's just pretty ugly.
Wait, what'd you do with the 3 over 3?
What 3 over 3?
The one right in the middle.
You used it to get
This?
the one right in the
I didn't do anything with this.
He's talking about the one.
This?
The one above the one.
The 3, no.
This?
If you're
3
missing-
times m is 3m.
Oh, okay.
It just looks like it's far apart because of all this stuff on the bottom. So 3 times m is 3m. 3 times this is over here now. Yeah?
Wait, can you explain why you used the 3 over 3 really fast?
Because of this 3 right here?
Okay.
So it's basically whatever you're missing on the other side.
Yep.
Give that.
Anybody just trying to make them.
What? Anyone? Alright. Whatever you're missing on, and this is exactly what Lane just said, and he summed up pretty good, maybe easier for you to understand. Whatever you're missing down here from the other side, you've got to multiply it. So here, we have an m and a 2, but we don't have a 3, so we need to multiply by 3 over 3. Okay? Over here, we have an m plus 2, we have a 3, but we don't have an m minus 2, so that's why we multiply m by minus 2. Okay? At 8. Moving forward.
God, say we just get on.
Huh?
I don't want to move forward. I just want to stop right
We
now.
only got 2 more.
That means you can example number 7.
The last one.
This next one's not too bad. Okay, so we have 5 over x squared minus 3x minus 28 plus 7 over 2x minus 4. 14.
Minus 14.
Yes.
Okay.
We need
Okay, we need to go ahead and factor the bottom. So 5 over.
7 and 4.
So
7 and 4.
x minus 7 times
X plus 4.
x plus 4. Okay, plus 7 over what? Okay, 2 times x minus 7.
Okay.
All right.
You need to multiply by 2 on the left.
And then on the right,
On the
you
right.
multiply by x plus 4.
Oh. Yay, we got it.
You know what's so funny is when I sit here and I listen to Colton answer questions, I'm like, man, if you remember the beginning of the year, I mean, Colton and Aiden were on the same level. Colton has skyrocketed to the top. Aiden's still working.
I'm still trying to spark that flow.
Oh, X plus 4?
And it's all my fault because I don't let him sit back in the back and touch Alexis.
Awkward.
Well,
Hey,
you don't have to make it sound like that.
I didn't make it sound like that. Y'all did. Y'all made it sound like that. All right, so now I need to multiply by 2, right? 2 over 2. And then over here I have adding 7 over 2 times x minus 7. And then I multiply by what over here? X plus 4 over x plus 4. All right, now 5 times 2 is 10 over 2 times x minus 7. X plus 4 plus
7x plus 4.
7x plus 28. Don't forget to distribute to the end. Over 2 times x minus 7.
Wait, where'd the 28 come into play?
7 times 4.
Yeah, distributed.
7 times x is 7x. 7 times 4 is 28.
Yeah, 7x plus 30.
Okay, so go ahead, Jackson.
So 7x
So we have 7x plus 38.
over 2 times x minus 7 times x plus 4.
Can you have 38 plus 7x.
It's fine, but you want to remember, if we think about order, we put our variables first and our non-variables at the end.
That was easier than any other.
No, I just think.
Hey, shut up!
That was
Is
the...
that it?
We got one more. This one's fun. The next one's fun.
It's gonna come out.
Okay, when you say it's fun, that means it's gonna take up like half a page.
That means we're going to take up a lot and then we're going to end up with a little. All right. Any questions on this? All right, moving on. Last example.
Real world application.
Okay. Real world application. College. Boom. Done. That's all you need. It's going to be in college. College algebra. First year.
Real world application job wise.
No.
I don't know, because you're going to be a disc jockey, so. All right, here we go.
Lights over here, 7 over there. What the hell?
That was weird.
Then you tried to be funny.
All right. Here we go. So, 1 over b plus 2, okay, plus 1 over b minus 5, all divided by, yeah. Yeah.
I was about to say, this is gonna be easy.
2b squared
I'm already done. Okay.
minus b minus 3 divided by
What is it?
What is wrong with you?
b squared
This is unacceptable.
minus 3b
Is this illegal?
minus 10.
Please divide it by something else. Please divide.
All of that divided by.
Brandon said I'm dropping out. I'm
Times the
done.
multiplicative inverse of it.
Okay, and this is really not that hard. Okay, now here's the deal. One of the things that I really do, and I think I do effectively, I'm not one of those teachers that likes to force it all at one time. So we're gonna go piece by piece. Okay, so
that we can end up.
no, hang on, we will. We're gonna rewrite it doing that in just a second. So let's start with this piece right here. Okay, when we start with this piece right here, we've got to get a common denominator. So I have 1 over b plus 2. What do I need to do here?
Multiply by 5.
Not by 5.
Negative 5.
Yeah, b minus 5 over b minus 5, right? Okay, plus 1 over b minus 5 times
B plus 2.
b plus 2 over b plus 2. Okay, so when you work that all out, you have b minus 5 over,
B squared minus 3.
no, b plus 2
Oh, yeah.
times b minus 5, right?
Yes.
Okay, plus
B plus 3.
b plus 2,
Over b plus 2.
b plus 2,
B minus 5.
Yo, but it's not the same.
b minus 5.
Oh, wait, it doesn't matter. It's multiplication.
Okay, so when I simplify this,
B squared minus
I'm going to have b minus 5 plus b, I'm sorry, excuse me, simplify this even more. B plus b is 2b minus 3 over b plus 2 over b minus 5. All right, so we just took care of the top part. Yes. Okay, so we'll put a pin on that and come back to it in a little bit.
Bye-bye.
So hang on to this.
We have, was it a trace in it? Yeah.
We'll come back. All right, here we go. So let's take care of the bottom part. The bottom part, what do I do to factor?
2b.
Okay, rooftop. Okay, so if I rooftop, I have 2 times negative 3, which is negative 6. So then I would do negative 3 times 2, right?
Yes.
So then I end up with 2b squared minus 3b plus 2b minus 3. Okay.
I'm not about this life.
Now hang on. Let's go ahead and factor this out. We simplify this.
Slow down. How'd you get that?
Rooftop.
Okay, don't explain.
Rooftop right here.
Marcus is the math block.
It's been a while back factor. We got to keep moving because of time. Okay. So we did the rooftop factor out here. I end up with b, right? And then I end up with 2b minus 3. And then over here I have 1 and 2b minus 3. So then my factors of just the top part are b plus 1 times 2b minus 3. Now I got to get the bottom part. The bottom part's significantly easier.
Drop down the B.
b minus 5 and b plus 2, right? So now my new problem is 2b minus 3 over b plus 2, b minus 5. Now, I'm going to skip a step because we're running out of time. But it's division, so I'm actually going to multiply by the reciprocal, right? So now I'm going to have b minus 5, b plus 2 up here. Okay, b plus 1 over 2b minus 3. I didn't ignore her. She figured it out, right? b plus 1's right here. Remember, I took this one because it's the bottom, and I flipped it, and I made it multiplication now. Okay, I have to. It was in the denominator, so I flipped it. Okay, hang on. Now look, watch what happens now. What happens here? Bye, goodbye, 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 and goodbye, and I end up with 1 over b plus 1.
Are you freaking serious?
So we did all that just to
Wow.
Yeah, I told you it starts with a lot and goes to a little.
I had that since the beginning.
Homework's on the board. Homework's on the board.